The collaboration we're discussing may be centered in Europe, but it is global in scope. And no venture better illustrates the international synergies and the potential of battery value chain innovation than the one that has put Berlin on the map when it comes to electromobility. I refer, of course, to Gigafactory Berlin-Brandenburg, which will be the most advanced high-volume EV production plant in the world. Tesla declared some impressive ambitions at its Battery Day this past September, and the Berlin-Brandenburg plant will play a role in realizing those ambitious aims. Joining us now, very early in the morning, his time, is Tesla's visionary CEO, Elon Musk. Elon Musk, absolutely great to have you with us, and thank you so much either for staying up late or getting up at the crack of dawn. Great to see you. So, you have been putting a lot of emphasis on battery innovation recently. I'd like to ask you about why that is and what you see as the most critical areas where improvement is needed, and also how realistic the chances are that we will see that kind of improvement. Mr. Musk, I think maybe your microphone might be on mute. Is that possible?
Yes.
There we go. Thank you so
me?
much. I can hear you very well. Thanks.
I did. Yeah. Okay. Well, thanks. First of all, thanks for having me. And it's an honor to talk to everyone. So as far as range is concerned, we I think have shown that the range can be very long. In fact, we could make it even longer than it is today. But our longest range vehicles have a range over 600 kilometers. And there's more. We could actually do more than that, and you'll see actually some improved versions of our vehicles come out with over 600 kilometers range, starting to approach 700 kilometers, and we even have some under development long term that can do 1,000 kilometers. So what we see is really the fundamental impediment to progress with batteries is the cost. So if you've got range, if you've got rapid recharge, and all those can be achieved, and a high calendar and high cycle life. So batteries can last like 15 years, which we believe ours currently can. Then what it comes down to most of all is improving the cost, so that the affordability of batteries of battery-powered cars, electric vehicles, is improved, and so that everyone can afford to buy an electric car. That's really what we see as the fundamental thing that needs to be improved. Now, along the way, there will also be improvements in energy density, which really translates to improvements in range. So, in pursuit of lower cost batteries, you actually end up in a lot of cases with improved energy density, which also gets more range. So the long-term goal would be to try to get to a cost per kilowatt hour of perhaps around 50 cents or 55 cents at the cell level for a long-range battery cell. And in order to get there, there are a lot of innovations that are necessary, both in the cell design and in the design of the factory that produces them. So, and in fact, there's quite a bit more work in building the machine that builds the machine than in the cell itself. So one needs to design the cell in the right way, and then the very difficult part, and I can't emphasize this enough, the very difficult part is then scaling up that production and achieving extremely high reliability and safety with the cells. So it tells us we've put a lot of effort into this over many years, mostly internally, but there have also been some key acquisitions that have been instrumental in achieving a lower cost per kilowatt hour. and that's what we intend to build at the prospective gigafactory in Berlin-Brandenburg area.
Just ask you, in terms of scaling up, what you see as the biggest hurdles to mass production?
I think um, there is the very element of scale itself, in that it's important to achieve economies of scale to make the batteries affordable. So things have to be done at extremely high volume. So that means a very big factory, and not just one that is big, but also one where um, the cycle time through the factory is very low. So you have fast cycle time with a big factory is what yields a high output. Um, in order to achieve a fast cycle time um, and a high precision, you need to develop advanced machinery for every aspect of the production system. So this is really everything from how the cell can is made to how the electrode precursors, the cathode and the anode precursors are made, to then making the anode and cathode materials, to applying them to the conductor. And for this, we have, for example, a very special process called dry electrode deposition, which is much better for the environment. It's basically allowing one to put on to apply the electrode to the conductive ribbon in a way that does not require solvent, and or require bake to then the normal way these things are done is you create a slurry of the electrode materials, and then you put this wet slurry on and with a lot of solvent, and that solvent is baked away by the ovens, and this is obviously suboptimal from an environmental standpoint, because you have gases coming from the solvent that you have to then get rid of. But with dry electrode processing, you do not need the solvent, you don't need the drying ovens, and you can apply it directly. This maybe sounds simple, but it's really very difficult. And in fact, a lot of the specialized equipment we use for this comes from Germany and elsewhere in Europe. So, but it doesn't exist. It's being made. It's really under design, and we've made it now at kind of a benchtop level, and we're aiming soon to have it done at a pilot plant level, and then the intent for Berlin-Brandenburg would be to have it done at scale. And scale in and of itself comes with a lot of design challenges it's a lot of R&D that's going to be done to solve this.
Talk to us a bit, if you would, in general, about your plans for the battery cell plant within the Gigafactory Berlin-Brandenburg. As you know, people here very excited about this. So what more can you tell us?
Sure. So we want to go from where we have a sort of small pilot plant, which is basically proof of concept in California, to something that will actually be, I think, possibly the largest battery cell plant in the world. I think it will be the largest. It would be capable of over 100 gigawatt hours per year of production, and then possibly over time going to 200 or 250 gigawatt hours a year. Pretty confident at that point it would be the largest battery cell plant in the world. And as I said, a lot of processes where we have to quite radically improve the cycle time, and where we have to redesign machinery for continuous flow operation. I've said this publicly on many occasions, that designing the prototype of really of any advanced technology is, I think, relatively easy, and then scaling up to high volume production is very hard. And In fact, there's an old saying, it's like it's 1% inspiration and 99% perspiration. I would say that it might be 99.9 in the case of battery cells. You'll see a lot of announcements of this cell breakthrough or that cell breakthrough, this technology breakthrough, and say, okay, well, why can't they just make a lot of them? It's because the scaling up of the production process is much harder than proving something out on a lab bench. So,
Great.
In fact, it might be helpful to provide everyone with just a walkthrough of the Tesla pilot plant. And if you see how intense it is, even at the very small pilot plant level, you can imagine how much more it would be at something that is perhaps 100 times more throughput.
Thank you.
Yeah, it's intense. Yeah.
Thank you so much for the inspiration-perspiration ratio there. I'll be taking that into some of our future discussions here at the conference when we talk about technology and breakthroughs. Let me ask you this, because we've been hearing all morning from the speakers on policy issues that they see sustainability as absolutely key to the European comparative advantage in this area. So you mentioned some sustainability considerations around solvents and slurry and so on. Could you say a little bit more about your view on the environmental impact of battery production and what you're doing at Tesla to take it toward a more sustainable direction?
Yeah, absolutely. As you highlighted, I think the dry electrode production process is, in and of itself, quite a game changer. It's a fundamental improvement compared to using solvent and then having to dry off the solvent and deal with the off-gassing from the solvent. That for sure is a big one. There are some proprietary methods by which the cathode is produced in the first place, where we avoid a lot of the steps that are difficult to deal with environmentally. And one of the things we're doing is we are reducing for example, the cobalt content. So that avoids like cobalt mining issues. So it would be pure nickel, or almost pure nickel anode. And then it would eliminate, like I said, a bunch of the steps of processing of the nickel electrode, which then obviously is good for the environment. We're moving to a high silicon anode, but it's a silicon anode where the silicon does not require it's not energy intense to create the silicon. It's using silicon that is comparable to solar solar panels, sort of photovoltaics. We also have come up with a means of creating lithium hydroxide without use of sulfuric acid. So it actually uses sodium chloride, essentially table salt, to extract the lithium from lithium clay deposits. And then that table salt is able to be reused. So there's really a whole series of steps that are employed to ensure that the environmental impact of the cell production is very clean, and that you could be living right next to the battery cell plant, and you wouldn't even have detectable amounts of any toxins in the air. So if you had like an air tester, you would not notice anything, literally. And it's notable that our pilot plant, that's the sort of basic proof of concept, is located in the San Francisco Bay Area, which is renowned for extreme environmental requirements. So if there was anything that was bad, it's really not possible to do it in the San Francisco Bay Area.
That will be very good news to those who enjoy the beautiful forest around the Gigafactory facility. So just a couple more short questions, if I may. One of them regards a long discussion about whether we will ever see electric trucks as being truly viable. And you started out in your remarks talking about range. So what's your response to the pessimists who say not going to happen?
Well, I think this is really just a fundamental calculation of you say, like, what's the energy density of the battery, of the cell, and then of the battery pack, and then of the integrated battery pack and truck chassis. So it's a sort of total mass uh, of the semi truck before, before including the trailer or anything. And can you get that mass down to something which is comparable to existing diesel trucks? And I think the answer is absolutely yes. And we've demonstrated that with prototype trucks. And so getting a range of, let's say, 500 kilometers is, I think, quite easy, like trivial, to be frank, for a semi truck. And this is assuming a truck that's pulling a load of something on the order of 40 metric tons. So it's a heavy truck. And then you can take the range, if you want, for long range trucking, up to, we think, easily 800 kilometers. And we see a path over time to get to 1,000-kilometer range with a heavy duty truck. This is, like I said, truck on the order of 40 metric ton total mass. And we think this is going to be extremely competitive and compelling to the trucking companies. And we actually have a few prototype semi-trucks that are in operation, have been in operation for over a year. So, some keys to that are having, like I said, a high energy density cell, and then integrating that cell into the pack with a minimum of extra mass, and then having a structural battery pack where the cells and the battery pack actually form part of the core structure. And this is also something that we talked about at Battery Day, and that we will be, of course, implementing with the semi-truck. And the net result is you're able to carry basically the same cargo as a regular diesel truck. Like we think maybe there's a 1-ton penalty, maybe, but at this point we think possibly you can even have less than a 1-ton payload reduction, and it could long term, I think, be 0 payload reduction for electric trucks. So sort of in terms of, like, to put numbers on this that are specific, something like around 300 watt-hours per kilogram, something like that, at the cell level, is enough to get to the high ranges that I talked about, sort of the 800-kilometer range.
Very interesting. Thank you. So one last question pertaining to something that you have said publicly, that both Gigafactory Berlin and Gigafactory Shanghai will be making original vehicles. Can you just say a few words about that? Give us a little more detail?
Sure. Yes, absolutely. So, I think there's just a lot of talented designers and engineers in Europe, of course, and I think, for a lot of the best people, they really want to work somewhere where they're doing original design work. They don't want to just be, doing, say, the European version of something that was designed in California. So I think it's important in order to attract the best talent, to do original design. And I think, possibly in Europe, it would make sense to do, I guess, a compact car, so perhaps a hatchback or something like that. And something that, like, well, what do most people want? And in a given region, or what is a very popular approach to take? In the US, the cars tend to be bigger for personal taste reasons, and in Europe, it tends to be smaller. And I mean, if you're trying to park in a dense urban environment, having a car that is that actually fits in a parking space easily is important. I was driving a Model X around Berlin, and we had quite a bit of trouble finding a parking space that we could fit. So I think that would probably be a good candidate for original design. but I'm sure there'll be others as well. But that might be the wise place to start. And it helps us also say, okay, we need a car that people can afford, that fits their lifestyle and everything. And so probably something like that would make sense. Um, yeah, I'm excited about doing some original design in Europe.
And many people here excited as well. So we will be following with great curiosity and interest the further developments. Elon Musk, thank you so much for joining us.
You're most welcome.
When I calculated the time in California and figured out what hour you must have gotten up at, I thought, has he actually succeeded in bending time, or is it really 2 in the morning? So we really appreciate your sharing your insights with us. And now I wish you a very good night and much success in future.
Thank you. It's good to talk to everyone. Thank you.
Thanks. Bye-bye.
Bye.